All right, I'm back. We're still on page 322. We're going to do the final example where we are supposed to find all the significant features of the function by hand. This is not a function that I'm familiar with, so let's see what we get here. So on working on the level of g of x, so on the original function, the zeros of the function you can see. So zeros are going to be at x equals 0 and x equals -1. Now, I look at this, and if x goes to infinity, I just get the fifth root of infinity, which is infinity, times infinity, so I get infinity. So there's not an asymptote as you go to infinity. As you go to negative infinity, the fifth root of negative infinity, I guess, is also negative infinity, and then times negative infinity. So it goes to infinity. So actually, it's going to go like, it goes up as you go to the left, and it goes up as you go to the right. So that's an interesting fact. So I think that might be all that we can get from the level of g of x. So now let's move down to g prime and see what we can do with that. Before I do that, so I could use the product rule on this, but I think it's probably better to rewrite this as x to the 6/5 plus x to the 1/5. Just distribute. So I can power rule my way through this, because usually that's a little easier. So g prime is going to be 6/5 x to the 1/5, because 6/5 minus 1 is 1/5, and then plus 1/5 x to the -4/5. Okay, so we definitely need to simplify this, because nobody could work with this. So to simplify this, what I like to do is go full fractions, and then plus x, oh no, sorry, everything's in the denominator of this, 1 over 5x to the 4/5. Okay, so the common denominator is 5x to the 4/5. So the left-hand fraction is missing x to the 4/5. X to the 4/5 times x to the 1/5 is x to the first. So I think our first derivative is actually just 6x plus 1 over 5x to the 4/5. Okay, so if we got that wrong, disastrous, but I don't think we did. So critical points at x equals 0, right? Because the derivative doesn't exist, but the original function does exist. So that's a critical point. And then x equals -1/6, because 6x plus 1 equals 0. All right, let's sign chart this and just see what's going on. So I'm going to put 0. Nope. Got to put them in order. Worst mistake, to put them in the wrong order. I almost made it there. -1/6 and 0. All right, so -1 billion. So if you look at the denominator, because eventually you're going to take a fifth root, but then you're going to raise it to an even power, so it's going to become positive no matter what. So the denominator is always 0 when it exists. What? The denominator is always positive when it exists. So if I plug in -1 billion on the top, I get negative divided by positive. So this will be decreasing. And then -1/6 is like a first degree thing, right? It's from a first degree factor, a factor to the first power. So there will be a sign change here. In my mind, if I had to test this, I would test something like -1 over a trillion, right? So I've already said the denominator is definitely positive. 6 times -1 over a trillion is basically 0, which means I'm doing basically 0 plus 1 is positive divided by positive, so I'm going to get a positive overall. So I like to do that kind of like use a super extreme value. That's why I'm always saying plug in a billion, plug in -1 billion. Here, I'm saying like, what's a number that's definitely in the interval, but like super close to 0? -1 divided by a trillion is really close to 0, but it is negative, so it is in the interval. So you can use that. And it basically zeroes out the 6x, which is why I choose to do that. And I think that's like a good skill to have. If you plug in a billion, you get positives everywhere, so just positives. Okay, so what can we say? We can say g of x is decreasing for x less than -1/6. And that's because g prime, sorry, is less than 0. So I guess I'll say it. G prime less than 0 there. Increasing. I'm going to break up increasing into two things because the like 0 kind of like makes me nervous. So I'm going to say g of x is increasing for negative 1/6 to 0 and 0 to and x greater than 0. Okay, neither increasing nor decreasing at 0, so like it's not the end of the world to like leave it out. And I think that whenever you're not sure, do something that you're definitively sure about, right? So I'm definitely sure that on those intervals, g prime is greater than 0, so I can definitely say increasing on those intervals. So there's a relative minimum at g at negative 1/6. So g of x has a relative minimum at x equals negative 1/6. And why is that? That's because g prime changes negative to positive there. Possible I could have, when I found the second derivative test, I maybe could have done the second derivative test. I'm not super excited about plugging negative 1/6 into any function, and the second derivative is probably high on the list of functions I won't want to plug that into. All right, so I think that's all we're going to get from g prime. Let's move to g double prime. So for g double prime, I'm actually going to go back here, and I'm going to power rule that because I do not want to use the quotient rule on the like final result. So I'm going back there. So g double prime. Problem is like I need to see that, and I'm really close to the bottom here. G double prime of x is, all right, so it's going to be 6 over 25, and then x to the negative 4/5. Okay, and then minus 4 over 25, x to the negative 9/5. And then obviously we're going to want to simplify this. So how do we simplify these things? We go full fraction on it. So it's going to be 6 over 25x to the 4/5, and then minus 4 over 25x to the 9/5. Okay, what is our common denominator? Definitely 25. And then you want the highest power of x that shows up in the denominator, which is x to the 9/5, which means that on the left-hand fraction, we're missing x to the 5/5 over x to the 5/5, just x to the first over x to the first. So our final version of the second derivative, before we even do anything, is going to be 6x minus 4 over 25x to the 9/5. Whew. Okay. So what do we want? We want a sign chart, right? So let's sign chart this thing. For g double, did I label my f prime? I did not. See that? Like as I'm going to do the right thing on g double prime, I remember that I want to label all of my sign charts. Otherwise, it gets a little confusing. I mean, if you're using different colors, it's less confusing. But you know, good practice here. G double prime. All right, so 0 is definitely going on there, and then 2/3 is going on there. All right, crazy, man. All right, now we got a test. So negative a billion. That gives me a negative in the numerator for sure. In the denominator, I'm going to take the 5th root and raise it to the 9th. So like the 5th root of a negative is negative, and then the 9th power is still negative, so negative. So that was a negative on the top, negative on the bottom, so actually positive through here. All right, let's plug in like 1 over a trillion. Right, 1 over a trillion gives me a negative on the top for sure because it's basically 0 minus 4. And then the denominator is positive because the 5th root and then to the 9th are both positive things. So a negative over a positive is a negative. And then a billion will definitely give me a positive here. Okay, so what can we say? X equals 0. So notice x equals 0 showed up on our g prime sign chart, but wasn't a max or a min. It is often the case that the things that show up on the g prime, f prime, the first derivative sign chart are actually points of inflection when they're not maximums or minimums. Not always the case, but sometimes it is the case. And that happened here. So we actually have points of inflection at 0 and at 2/3. So let's say that. So POI at x equals 0, x equals 2/3, because G double prime has sign change there. We don't care how. We just care that it happened. All right. So points of inflection there. Concave G of x is concave up on, I guess that's an O, on x less than 0, x greater than 2/3, because G double prime greater than 0 there. I don't really like ending it with there, but for space reasons and expediency, I usually do. And then G of x is concave down on 0 to 2/3, because G double prime is less than 0 there. All right, so we got a lot of features, and I think what we should do, why can I not scroll this? I guess I'm like as far over as I can be. Oh, maybe if I like make it big, I don't really know. Can I move my face? I don't actually know if on the recording this moves my face or not, but I've done it, so I think it should have. So these are all of our features. Let's go to the calculator and see. This is like a crazy function. I did not like offhand, just thinking about it, know what this thing would end up looking like. So new problem and a graph, and our function was x to the 1/5 and then x plus 1. All right, so oh my gosh. Really interesting looking function. All right, so we thought there would be zeros at -1 and 0. And you can see visually, I'm not going to clutter it up. You can see that at -1 and 0, there are definitely zeros. We thought that we would decrease until -1/6. So let's find this minimum. So there's a minimum on this function here to here. That is -1/6. So decrease until -1/6, increase ever after, and we kind of got that. I mean, we definitely got that. There's something very weird going on, like around 0. In fact, let's zoom box around there and see if we can like get a better idea. So this is a very extreme point of inflection, I think, at 0, and a much subtler one at 2/3. So we got all of our increasing, decreasing, we got the minimum correct, we got the zeros of the function correct. Concavity. Let's see if the calculator can do it. So we thought that there was an inflection point at x equals 0. I'm not sure if it'll find the ones where the second derivative is undefined. Oh, it doesn't. Look at that. What if I keep going? Okay, it finds the one at 2/3, but it doesn't find the inflection point at 0. I think it doesn't. I mean, it like, I don't know what pretty obviously means in this case, but I think it pretty obviously does have one. We're going to zoom box like a funny way here. Like you can see there's a change. We're concave up and then we're concave down. There is a point of inflection there. Calculator can't find it. I'm thinking that the built-in thing is only looking for where the second derivative is 0. It doesn't have a way of figuring out where the second derivative is undefined, which is what happened here. If we add a calculator page, let's solve menu 3.1. Let's solve the second derivative. So the second derivative with respect to x of, our function is currently in f1, so let's just use that, equals 0. Oh, this won't do it either. Equals 0 for x. What if I do domain of the second derivative, where x is the variable? Okay, so that did nothing. What if I find, let's see, if I find the second derivative and then ask for the domain? Okay, let's see, domain of the answer. X is not equal to 0. So now I have my candidates, right? It's the places where the second derivative is 0 or undefined. So at 2/3 or at 0. And now I can do like a fake sign chart type deal, like do such that x is something less than 0. So -1, positive. between 0 and 2/3 is like 0.1, negative, and then greater than 2/3, so like 1. I don't know why I'm getting so close to the values. Like I should go like huge, but you can see that there are those sign changes. So limitation of the calculator, not its fault because it's complicated to do these things, but it apparently can't find the, well, did I try one more time? I don't remember if I did or not. Apparently it can't find the points of inflection that result, yeah, it's just missing it, no inflection, where the second derivative is undefined. That's fine, because it gave us a lot of information anyway, but we got it. So this is a very weird function, but knowing the calculus allowed us to find all of the key features, and that's a big deal. So let's go back to the notes. There's like a video a couple back where I stopped while on the calculator and like, ugh, so weird. We're back on the notes, and you can see we did a ton of work, right? But this page is in the books, so I will be back to keep going, and I'll see you in the next video. So hope you're finding these helpful.